I am gonna record this session. So this is confidence intervals. We were talking a lot last class about the importance of a confidence interval. So we have a sample. We don't know the mean of the population, but we have a sample. So we can build a confidence interval that allows me to make inference with the population. So once again, I build this, I draw a sample, and very likely the population mu, the population mean is going to be contained um, in that interval. So this is my um, sample mean. So I build my interval. So mu, wherever it is located, is within my confidence interval. So in this case, um, this is not this interval is not part of it, does not contain mu. So in this case, this is a 90% because we have 10 observations or 10 samples, and out of the 10, 9 contain mu, one does not. So you just imagine that you do this 95 times. So very likely 95 samples are going to contain mu, 5 of them are not. You choose a 99 confidence level, that means that 99 of these samples are going to contain mu, and one probably will not. So we mentioned that this is not correct to say that there is a 90% probability that the actual mean is in the interval. So we can say that if a large number of samples is collected and a confidence interval is created for each sample, approximately 90% of these intervals will contain the population mean, will contain mu. So that's very interesting. So once again, you are reporting results. I guess you can report your results with the standard deviation. So you are taking the mean value of something, and then you say, well, this is the standard deviation. So that's good because you can talk about the degree of variation. So confidence intervals allow you to make even more inference in your case. So in this case, in many cases, confidence intervals are very important. I was mentioning that in many cases of health sciences, I have seen this very often. Most of the results are based on confidence intervals, not on the basic statistics that we do, and that's very good. So in many cases, what we have to be aware of is whether the confidence interval is very narrow. Like for example, if your mean value is 3.5 and your confidence interval goes from 3 to 4, you say, well, that's understandable. But if go from 1 to 20, so that's a very big, very wide confidence interval. So those things are very important, and whether the interval contains 0 is also something that we should see. But so in this case, we are dealing with the basics. So all we want to do is to just let know the other researchers and your audience that based on your appraisal, um, um, you have a 90 or 95 or 99% confidence that the mu is contained in this interval. So, so today we are gonna, well, also we talk about the sample size. So given a confidence interval, a C confidence level, and a margin of error, the minimum sample size needed to estimate the population mean is given by this formula. So we need the C score, we need sigma, and also we need the margin of error. So we put this together, and we have to, so we have an approximation of how many people, how many individuals, how many units in the sample we need to account for. So so we as I mentioned before, probably if we are using Facebook, Facebook is very big. So a small sample probably is going to be informative, but it will be better if we use this formula to find the proper sample size. And remember, in many cases, sample sizes are not easy to achieve because, for example, if you are doing a study, so hiring researchers, hiring people who collect the data, and doing all these things is very costly. So in many cases, sample size, of course, we want a big sample, but in many cases, it's not economically feasible. So that can be one of the things that this can help, because I can determine exactly how many people are gonna make my results more significant. So so we have this case, we have the C-score. So remember, we were looking at these cases of the C-score. So so we find how to find the C-score based on the probability. So we find the C-score. Once we find the C-score, so we already have data on sigma. And we are assuming that 7 confidence in margin of error, right? So if I solve for this, so in Excel it's going to be very easy, I guess. We just can sample size equals to. So let me make it a little bit bigger. View, zoom, 150. So sample size. So here we have, so we are going to use this data. The C-score is equal to 1.96. Well, in this case, well, hold on. So let's do this properly. We have a 95% confidence level. So we are going to find the norm that is that IMV of 0.025, right? Or we can find the 0.0975. So let's do that, 975. So we have this, so we have 1.96. So then we have here sigma. This is a sigma, not an S symbol. So we have a sigma that is equal to 53. And we have a margin of error, the margin of error that is equal to 7, right? So my formula for the sample size tells me you have to take, let me open, I'm gonna say Z times my sigma, then that is gonna be divided by 7. And all this is gonna be squared. Okay. Did I do something wrong? Oh, it's a square to the power of 2. Sorry. Okay, so I forgot to raise this to the power of 2. So this is C times sigma divided by the margin of error and then squared. So we have the sample size. So we want to improve, so we want to make a margin of error narrower. Probably instead of 5, I will use instead of 7, I will use 5. So we need a bigger sample, right? So just changing the parameters of the margin of error, so allowing a bigger error is going to be, so we can get a smaller sample. So you are happy with 5. So you need at least 473. So it also happens when you change any of these parameters, okay? So, so if you change any of these parameters, of course, you are gonna be making this bigger or smaller, right? So you want to change the level of significance. Instead of being 95%, you want a 99%, right? So we want a 0.5. That's the, so 0.09995. So you need 380 subjects in your sample if you want to do this with more with a higher level of significance. So this is very interesting. That tells you what are the things that are important in your sample. So I hope you can play a little bit with this because that's very interesting. So for example, you want to look at well, you need information on this, on sigma, the level of significance, and of course the margin of error that you want to allow for this study. Okay, so so we are gonna do something today. So basically, what we did today, or last class also, was to find the margin of error. Well, to build a confidence interval for a sample where we know sigma, right? Or the sample is big enough that we can use the standard deviation of the sample instead. So in this case, so I was mentioning this sample is big enough, is normally distributed, and then so we already know the distribution. So so what we can do here is use this Excel. So let me make a note. So this is basically what we're gonna do here is basically this, right? Constructing a confidence interval, constructing a confidence interval when sigma is known, right? So in this case, sigma is known, or our sample is at least is greater or equal to 30, and is normally distributed. Okay, so okay, so we are going to construct this. So let me use a red font so we can identify this. So in this case, what I want to do is I want to build a confidence interval. I'm going to forget about all this math, which is not difficult. It's very simple, very simple math. And instead, I am going to use the Excel function, which is so to find the margin of error, we are going to use confidence norm. So we are going to build a confidence interval. Basically, what this does is that gives you the margin of error, right? You have to do the additional math in order to find that value in your mu. So in this case, in order to find the margin of error, we need a couple of things. I think I mentioned that before. We need alpha, and alpha is going to be equal to 1 minus C, right? So in this case, we have an alpha. So let's use this case. Alpha in this case is 95%. So I'm going to say equal 1 minus 0.95. So I'm going to do an alpha equal to 0.05. So this is already telling me what is the value that I'm going to choose for my C-score. So I don't need to compute the C-score. If I need the C-score, of course, I'm going to come back here and remember we found the C-score. We use this with the probability. So in this case, I don't need the C-score. All I need is alpha. So alpha is going to be 1 minus C. So let me use the same notation, probably. It's going to make things more clear. So alpha, I'm going to use the symbol. Okay. So this alpha is going to be equal to, so alpha is going to be equal to 1 minus C. And I know in this case, my C was equal to 95%, right? Which is 0.95. So I don't need to separate. I don't need to find the critical values. Of course, if the critical values are requested, then I have to use this. If I have the level of the level of confidence or the confidence level, so I can find the critical values very easily as we did it before. So in this case, I don't need it. I just need to know what is the margin of error, right? So here we need the standard deviation. So let's go back here. So the standard deviation was 53. And the sample size here was very important. We have 40, right? So once I hit 40, this is going to change. So I am inputting all the information. This is a formula. So as you can see, this is a formula, is equal confidence, that norm. So it's asking me for alpha. So remember, I don't need the C, I need alpha here. I need the standard deviation and I need the sample size. So when I have this, I find the margin of error. So let me make this smaller. There are too many zeros, too many. So probably if I want more than at least 2. So here, my X bar was already determined at, so we had a value of the X bar, right? So 130.8. So this is the 130.8. So I'm gonna build this confidence interval. I'm gonna say equal, this is X bar, this is the lower limit minus the margin of error, and then my equal my X bar plus the margin of error, right? So so we have these values, I guess. I don't know why they are a little different. 130.8, margin of error 16.4. Yeah, that's the same. 114.4, 147, and 27. So as you can see, this is very simple. As I was mentioning before, we are gonna compute these values here. But in many cases, when you are using software, so you are gonna be very familiar with these things. So in many cases, you don't have to compute them, but at least you know how the confidence interval was built, and you can rebuild it, of course, if you have the margin of error. Sorry, if you have some of the elements, you can find, for example, the level of significance or the value of the standard deviation. So you can compute those values without any problem. So I hope there is no questions. I don't have many exercises, but this is very simple. So once again, all we need to identify here, once again, is the confidence level. And then with this, we build our alpha. Then we need the standard deviation, and we also need the sample size. So once we have these 3 values, finding the margin of error is going to be very, very simple. Okay. So I hope there are no questions, because this is very simple, and I guess we talked a little bit about this last class. So today we are going to have a case. So in this case, this statement is very important, because we are assuming that we know sigma. So when we know sigma, we assume normal distribution. Or when my sample is big enough, I can use S, and I can assume also normal distribution. So in some cases, I am gonna be kind of screwed because I don't have sigma and I don't have a big sample, right? So in that case, can I use the normal distribution? So the answer is no. I cannot use the normal distribution because the normal distribution, as we mentioned, only applies for samples that are normally distributed or are big enough, and we can assume normal distribution. We can use the central limit theorem and approximate this to the normal distribution, but we don't have it. So in this case, we are gonna do something different. So, so in this case, we have the additional case where we have to build a confidence interval for a sample that is small. But it's not only that the sample is small, it's also the fact that we don't have sigma, right? So that makes the issue a little bit different, right? So when the population standard deviation is unknown, so the sample size is less than 30, and the random variable is approximately normally distributed. So we still have faith that our sample follows a normal distribution, but we cannot apply the central limit theorem. So we are gonna use an additional tool that is called the t-distribution. So the t-distribution, as you can see, is also very similar to the C-score. So we have the random variable, we have mu, and then we have the so-called standard deviation. But in this case, remember, this standard deviation is not sigma, is the standard error. So is the sample size, standard deviation of the sample divided by the square root of the sample size. So is the standard deviation of the sample divided by the square root of the sample size. So we are gonna find, as in the other case, the critical values that are denoted by TC. So remember in the first case, when we were looking at, well, we are gonna look at this in the same way. So properties of the t-distribution is basically very similar, but it's applied and adjusted for a small sample. So the t-distribution is bell-shaped and symmetric about the mean. So it's very, very similar to the normal distribution. So this t-distribution is a family of curves. So each curve is gonna be determined by a parameter that is called the degrees of freedom. So degrees of freedom are the number of free choices left after a sample statistics such as X bar is calculated. So when you use a t-distribution to estimate a population, the degrees of freedom are equal to the sample size minus 1, right? So if I have a sample size of 20, if I have a sample size of 20, so my degrees of freedom are gonna be 19, right? So it's n minus 1. Just give me 1 second. So my degrees of freedom are gonna be sample size minus 1, okay? So this is very important because in order to find the t distribution score, I need the level of significance, and I also need the degrees of freedom. So those are very important to find these values. So the total area under the curve, as in the previous distribution, is equal to 1 or 100%. So the media, the mean, and the mode of the t-distributions are equal to 0. That's very similar to this. But as the degrees of freedom increase, the t-distribution approaches to the normal distribution. So after 30 degrees of freedom, the t-distribution is very close to the standard normal C distribution. So here we have the shape of a t-distribution when the degrees of freedom is 3. So when the sample, sorry, when the sample size is 3 and the degrees of freedom are 2. So as you can see, this line is above the axis. So as the degrees of freedom increase, so that approximates to the normal. So remember, the normal is an asymptotic curve. So that means that it goes closer and closer and closer to the axis, but never touches the axis, right? So in this case, very similar, as the degrees of freedom increase, we are looking at something that resembles the normal distribution. So this is very very helpful because we can find significant values for small samples. So the tails in the t-distribution are thicker. So as you can see, the distance between the curve and the axis is declining. So this distance is declining as the sample size increases and thus the degrees of freedom. So than those in the standard normal distribution. So you might need to use this because, for example, we have, well, we are going to find a I don't know if I have here that no, I don't have it, but I have a Excel. I'm very distracted today. So I have an Excel function that helps us to find the t-distribution t-score, okay? So don't worry too much. The goal here today is gonna be to find the margin of error and then being able to do our confidence interval, right? So this is the example of the values of t. So for the critical value, TC, 95% confidence. So, and this is when the sample size is 15. So remember, with this 95% and this sample size, I'm gonna identify the degrees of freedom. So I need degrees of freedom and level of confidence, and I can find the value under the, so the critical values. So that basically means the following. So, well, I think I have it here. I don't have to do it again. So in this case, this is the 95%. So my critical values, of course, here, I'm gonna assume that this is symmetric. So this is 95. So I don't care how much is here. All I want to find this level of confidence. Sorry, these are critical values. So once again, let me do it here. So to find the critical values here, I need the level of confidence and the degrees of freedom, right? So all I need to do to find these values in my table. For example, here the confidence level is 95 and the degrees of freedom was how much? 15 minus 1, right? So in this case, I'm going to use the table. I'm going to use the 95 level of confidence. So as you can see, there is a little thing here, level of confidence. So I'm going to look for the degrees of freedom, in this case 14, and then the value I want to accomplish, right? So in this case, I find the table, in the table that this value is going to be 2.45, right? So I'm gonna basically use my my sketch of the t-distribution, and I am gonna identify my values, right? So very simple. We are gonna use this formula. So to find the area under the curve. So so we are gonna use this formula to find the area under the curve. And then, so we are gonna use this t-score in order to find the confidence interval, right? So, so once again, all I need is confidence sample size, and I also need information for the margin of error. So this margin of error is going to be given. It's very similar to the one before. We are using the t-score here. In the past, we used the c-score. We are using sigma, sorry, the sample size, the sample standard deviation divided by the square root of the sample size. So that's what we need in order to build our confidence interval. So I need mu, I need t, and I need sample size and sigma, right? So, so in this case, the probability that the confidence interval contains mu is C. So even though this is a very small sample, we are going to be able to make some inference. So these kind of tests are very important. Just imagine that you are working for a pharmaceutical company, right? So, and they are gonna test, or they are looking forward to analyze a vaccine. They don't know how the vaccine works. So you take a very small sample, you test the sample, and then you find the statistics that make you believe that probably this is a very good result, right? So if you, so if that that sample is good, so so you can use. So the point I'm trying to do, this T score basically is good for small samples, and in many cases, the big clinical trials always start with very small samples. So remember, clinical trials go from the phase of testing the efficacy of the medication. So they give the vaccine or the pill to a very small number of people who are basically healthy people. So they are looking at the toxicity. Then when this is good, they expand the sample. Probably they are using a fairly small sample to find whether or not the vaccine or the pill helps to cure the disease. One is to identify whether it's not toxic. Then the second is to identify whether or not it works. And then if it does work in a small sample, that's when the big clinical trials start taking place. So so that's a big thing. So this T computation makes a lot of sense. We are going to be using the T distribution a lot from now on. So just keep in mind that in this case, we are going to use the T test or the T distribution to find the confidence interval when we don't have sigma and my sample size is below 30 units, 30 individuals or 30 elements. So here, so we are going to identify the mean. So we are going to find the standard deviation. Of course, that's not going to be difficult. Then identify the degrees of freedom, then build the margin of error. So if we are doing a step by step, that's how it looks. Then once we have the margin of error, we subtract the margin of error to find the left endpoint and then add it to find the right endpoint. And then we build the interval. And then we make this nice statement that we usually make at the end of our case. So we can do it by hand. You can do it by using your tables and everything. So in this case, you have a Excel function that is also for confidence, but in this case, is looking at the T distribution. So I don't need to do almost anything to find the T scores. So we can find the T scores later. But in this case, the goal is to build the confidence interval. So what I'm going to do is I'm going to use this Excel function to find the the margin of error when sample size has no sigma. So here, let's write it. And you can write it too. So finding confidence intervals when sigma is unknown and sample size is less than 30, right? So then that's how we can see that this is going to be, so what we are going to do here, my sample size is going to be relatively small, and my, so I don't know sigma. So in this case, let's look at the case. So it's very similar to the previous one. What changes once again is we don't have sigma and we have a very small sample. So in this case, I'm gonna type the values here. So the problem says as follows. You randomly select a coffee shop and measure the temperature of the coffee sold at each. The sample temperature is 162 degrees with a sample standard deviation of 10 degrees, all of those Fahrenheit, right? So find the 95% confidence interval for the population temperature, mean temperature, assume that the temperatures are normally distributed. So we know that this sample comes from a normally distributed population. So we can apply the t-distribution. So we cannot apply the C-score. We cannot use the C-score, and instead we're going to use the t-distribution. So here, what we have here is n, which is this, is the sample size of 16. I have the x bar, which is equal to 162. And we have the standard deviation, which in this case is S, because we don't have the population, we have the sample standard deviation. So in this case, it's 10, right? So what do we need here? So here, and we know the we know the confidence level, which is equal to how much did we say? 95%, right? So we have a 95% level of significance. Thus, my alpha, so in this case, remember, for my Excel function, I don't need the C, but I need alpha. So in this case, my alpha is going to be equal to 1 minus, equal to 1 minus the 0.5, right? So we have a 5%. So that's what I'm going to use here. So in this case, I have all my information to find the confidence interval, but also I need to include here my X bar. So well, here my X bar was 162, right? So I think that's when we are going to build the computations. So so and remember, this is going to be equal to the X bar minus whatever I find here. Oh, sorry. Whatever I find here is A2. And X bar minus plus whatever I find here, right? So of course it says, I don't know what it means because I don't have any number here, but at least I have these formulas. So these formulas, let me put some green here because so those are the values that I am, those are formulas, right? So that's the reason I put different colors sometimes, because those are formulas. So here, I need the alpha. So I have alpha here. So equal to this, to this value. Then the standard deviation is going to be 10, right? And my sample size is going to be 16, right? So once I press I press enter, I'm going to find these values here, and I'm going to find the values of my my confidence interval, right? So 5.2, too many zeros. Let me make it smaller. Probably 2 is too little. 3 is fine, right? So here I just want 3. There are too many, and that drives me crazy. Okay, so we have 3 different decimals. You can adjust it according to what the question is asking you. Many times, or most of the times, Excel sampling learning is very specific, and using Excel helps a lot. So in this case, we found the confidence interval. So let me move this at least one little here. So so we use the t-distribution once again because n is less than 30, sigma is unknown, and the temperatures are normally distributed. So we find the values. So we found the t score. So and then we built our margin of error. So in this case, the margin of error is 5.329. So this is this one. So my upper limit is 156.67, and my no, this is the lower limit and the upper limit. So remember, we have to write the statement. So with 95% confidence, comma, we can say that the population mean temperature of coffee sold in that store is between 156.7 and 167.3. So that's very good, because we, by taking this small sample, we are building this confidence level. So we can see that my confidence interval. So I might expect that the population mean is going to be somewhere in between, right? So somewhere, a place that I don't know, but at least I can tell you that with 95% confidence, that is the value of mu might be contained in this interval. So probably I want to make it even more precise. So I want a 99% confidence interval. Why not, right? So so in this case, we have a 1%. So that's the reason I like to use Excel, because in this case, we can make changes, and we are going to be, I mean, we just can change some of the parameters, and we are going to obtain these results. So as we can see, because we have a confidence interval that is more precise, I would say. So this confidence interval is kind of wider. As you can see, when we have the 95, this is 156 to 167. So it's kind of a little bit wider. And the reason for that is, if you look at the X bar and you look at the standard deviation, so there is not too much variation. So let's say that the standard deviation here, instead of 10 is 110, just to give you an example, right? So that is going to do so many things in here, as you can see. So because the degree of variation is very strong, so the confidence level, or the confidence interval, is wider, is way wider. So that probably is going to be an indicator that the sample is, the variation in the sample is very strong. So in this case, we just keep the 10. So we can see that the the confidence interval is fine. Okay, so we have this case. So question again, whether to use the normal or the t-distribution. Well, this is very helpful because, for example, is your n greater than 30 or at least 30? And the answer is yes, yeah. You don't have to ask any question. Just go ahead and use the normal distribution. So remember that in this case, you can use sigma if you have sigma, if sigma is known, or you can use the sample standard deviation if your sample is big enough, right? So you can use C, and here you can use sigma, or you can use S. So if your sample is less than 30, so is the population normally distributed or approximately normally distributed? So if you have data that shows that you have a small sample, and for example, you have a rectangular distribution or a binomial distribution, so you cannot use the normal distribution or anything, any approximation to the normal distribution. So the answer is you cannot use the normal distribution. But what happens if you have a binomial that is the sample size is 40? Yeah, of course. Any sample that is 30 can be approximated to the norm. So that's the beauty of this. Any sample big enough can be assumed to be normally distributed. So in this case, if this is not, if I have a sample smaller than 30, but is not normally distributed, I cannot use normal or the t-distribution. But if the answer is yes, the first question, do we know sigma? So if the sample is small and we don't know sigma, so we have to use the t-distribution, right? So that's what we said before. If we have a sample that is small and we don't know sigma, we have to use the t-distribution. And remember, to find the t-score or the t-critical values, we are gonna find, we need to know the confidence level and we need to know the sample size. So with the sample size, we can compute the degrees of freedom, and that's gonna be the key to find these values. But even if the sample is smaller than 30 and sigma is known, so we can still use the normal distribution. So the key point is whether or not we know sigma and whether or not this sample is greater or lower than 30, okay? So is there any question so far? Is there any question
Hello?
so far? Yes, Al?
No, it's goodness. Is the margin of error the same as the standard error?
It's the margin of no. No, the margin of error, remember, so this is the margin of error, right? So the margin of error, either the T or using the T or the C, is gonna be given by the test statistic multiplied by sigma. So this is the margin of error, right? So this is the margin of error in the two cases with the C score and the T score. In this case, that's a very good question. So in this case, this is the standard error. That's a very good question because we are multiplying the test statistic times the standard error, okay? So remember that the standard error is given by the degree of variation divided by the square root of the sample size. So that's when we account for samples. So in this case, are the margin of error equal to, no, those are two different things. You need the standard error to compute the margin of error, okay? Is that clear?
Okay. Yes, it is. Thank you very much, Professor. Also, is the Excel sheet up yet?
It should be up. It should be up. So if you can go and so let me make sure that my answer is accurate. So by the way, the new class is here, the first part of the confidence interval. So if you go to module 4, you go to confidence intervals, and then you go to CI class SP 2020. So you have the PowerPoints and the Excel file, okay? So
Okay,
we have, So we have another
Yep.
Excel file for hypothesis testing. That is a little bit longer. So we are going to use our classes like a lot. The next, I think we have one more class for this, and then we have 3 more classes, Wednesday, Monday, and Wednesday, and then the assignment. So we have plenty of time. So my point is, you also have an Excel file here for the next assignment.
Yeah, Professor, I'm asking because I'm looking at it now, right? And out of the 5 sheets that are there, only one of them has an actual problem to do. And that's the first sheet, the one that says short example. The large sample, the small sample, the proportion, and everything else after that, there is no problem to do.
Well, that's what we are doing in class. Yes, yes, absolutely, absolutely. My goal for here is that you learn how to do it, and then you use it in your. So what we are doing here, I am expecting you to just follow what we did, recognize. Like you can use one of the. So that's a very good question. Thank you for asking. So you can just do what I did, and then it's fine. But let's say that you identify that one of the examples in sapling learning is confidence intervals for a large sample when sigma is known, okay? So we did this in class. I'm gonna copy and I'm gonna paste. So I'm gonna say paste, right? So that remains the same. I'm just gonna erase these numbers, right? So if I find, like, for example, exercise 5 in problem set, I don't know, I think it's, so this chapter is what? Well, confidence interval, right? So I know that exercise 5 has an example for confidence intervals when the sample is large, and I know sigma or something like this, right? So you can just solve it here and say, look, I did it. So I will revise it, and that might be good. Thank you for asking these questions. So, and you are absolutely right. All these are empty. So as you can see, there are no values. But if you use it when you are doing your homework, that's going to be the value that I want. Okay? Is that clear?
Oh,
Or
wow.
that
Oh,
is
that
very
is
good. I mean,
ah 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 ah
practically
ah.
speaking, you will see when we look at the standard deviation and the confidence interval for the standard deviation and the variance, it's not difficult, but it's complicated math and too many steps. With this, I'm gonna give you guys something that is already to go. So you can find, but we will see that. So I don't want to jump ahead. But this is very helpful, and that's a very good question. Try to do what I did in class, and then if you identify at least one of the examples, I will be happy. Okay. So find one of the examples for the large samples when you know sigma, or the sample is greater than 30, or when you don't know sigma and you have a sample less than 30 and you have to use the so you have to use the T score. So if you have this, you just can copy. So it's as easy as this. You copy, you paste it. So this, please do not erase. But these numbers you can erase and feed again, right? So this number again, right? So even I'm gonna remove the color from here. So because those are values that we need to enter. So here are values that we need to enter. So so here you need to enter alpha. So I just copy and paste it and erase the values. So I didn't erase this because it's a formula. I didn't erase this because they are formulas. Okay, is that clear? So you said it. I mean, it's very simple, and I found that when I teach this and students, So if I go step by step, it's very tedious and it's very, I don't know. This is a straightforward and I think it's less complicated. But anyways, let me save a little bit of, hold on. So proportions. So let me see how many more slides we have. Oh, we have a lot. So let me continue at least with more. So we are supposed to cover at least 20 slides. So, so once again, we have two cases so far, samples that are big enough and sigma is known, or samples that are smaller and sigma is unknown, right? Or samples that are small, but we know the value of sigma. So we can be very careful which one is the tool that you need, because in most of the cases, the examples that you have to solve, they exactly tell you what they want they want you to do. They said this is a t-distribution and something like this, but you should be able to make the judgment on your own. Okay, so so next one, so normal or t-distribution. So of course use the normal distribution. Here's the solution. Let's see why. So you randomly select a sample of 20 newly constructed houses. So first question, is this sample bigger than 30, lower than 30? Well, it's lower than 30. So that might be a good candidate for a t-distribution. I need more information. So the sample mean, okay, I have the sample mean and I have the population standard deviation. So the population standard deviation is what? Sigma or S? Is sigma, right? So I have sigma, even though this is a small sample size, smaller than 30, they are giving me the population standard deviation. So with that, I assume that is sigma. So that sigma allows me to use the normal distribution. So assuming that the construction costs are normally distributed, should you use the normal distribution, the t-distribution, or neither to construct a 95% confidence interval for the population mean construction cost? So once again, you have a sample very small, and you are claiming basically that these values are representing the values of the population. How confident, how sure you are? Well, I'm 95% confident. So that's the reason when you are explaining your results, you have to explain this, right? In some cases, people, for example, they report results as follows. For example, you have an X bar. So you have an X bar, let's say that is equal to 20, right? And then you build a 95% confidence interval. So this is 95%, right? That goes, let's say 17.5, 22.5. So in many cases, that's how people report these values. So type in, we have enough, I mean, not exactly works in real life. That's what people do. They report the 95% confidence interval. So here, let me do it better. 95%, right? Is 95% CI equals to 72. So that's how in many cases you are reporting your results. You are typing like, okay, I use a sample of 30 people, 25 newly constructed house, and the mean construction was 181. So with a 95% confidence interval between these two numbers. So that's the way you report it. So do it with a statement, probably is good. It's also very good. But so in some cases, when you are reporting your results, So this is very, very nice to do. So I think I was kind of showing my, not because it's the big enchilada, but that's the way sometimes you report findings. So in this case, we were looking at these COVID values. And for example, here, so when you are reporting your results, for instance, you are saying here in this case, the morbidity models show that income is protective. This is the value of my odd ratio. It can be a mu, anything, with the 95% confidence interval that goes between these two numbers, right? So also the odds of dying from the disease, this is the statistic, and this is the confidence interval. So that basically tells the reader that, oh, okay, well, doesn't look too far apart. I think so the degree of variation might be good. So it's a very strong statistic, very, very strong statistic. So in this case, for example, the one that we find with 37, this one, so we can see that the confidence interval is very, very wide, goes from 5 to 267. So that probably means that the degree of variation of whatever this is being, whatever we are measuring here, is very wide. So and sometimes you do so much math, and when you report your results, it's just like a single line, and it's like, oh my God, I did so much work, and this is the way I have to report it. But that's the way it is, and things are like this. So in this case, we use the normal distribution. The population is normally distribution, and the population standard deviation is known. Okay. So so we also have the population proportions. So in many cases, we are not reporting mean values, but we are we are using proportions. For example, if we have 100 people, so my sample size is equal to 100, right? Out of this, we have 65 women, and we have 35 men, right? So very simple, the proportion of women, how we can do this, the proportion of women, is gonna be equal to the number of women, right, divided by the sample size, right? So in many cases, what we are gonna do is we are gonna report values based on percentages. And that is very good. That is very good because we are gonna be able to use percentages, use proportions in order to find the confidence interval, right? So I don't know the population proportion, but I have a sample that I collected from somewhere, and those are the results. Can I know that if this proportion reflects the population? So we can build that confidence interval based on values that we know, right? So in this case, we also need more information before being able to solve this case. So confidence intervals for population proportions. So the point estimate for the population proportion basically is the sample proportion, right? So the population proportion, the probability of success in a single trial of a binomial experiment. So that's when we are going to use this concept of binomial, and we are going to be able to use the normal distribution too. So in this case, we're going to assume that this probability of success and probability of failure, so it's going to be based on a sample that is big enough to produce data that can be approximated to the normal distribution, or make a normal approximation. So the population proportion is denoted by P, right? So P is going to be the population proportion. Like, for example, I know that Lehman has a proportion of women, let's say 65%, right? So I go collect my sample and I find something like, let's say 72, and then this is 28, right? So something like this. So I want to know how likely is that these values are reflecting the population proportion. So in this case, I'm going to take a sample. So I go to Lehman, I take a sample of 100, 200, 500 people, and then I find the sample proportion. This sample proportion is going to be denoted by the p hat. So as we can see here, p hat, the p has a circumflex accent. So p hat is nothing else but the number of successes in the sample divided by the sample size, right? So if we know p hat, can we know q hat? So the answer is yes. So when we have p hat, and we know that p times q hat is equal to 1. So if I have p hat, I can find q hat. Sounds like a tongue twister, but you get the point. So the point estimate for the population proportion, of course, is going to be the sample statistic. In this case, is the sample proportion. So remember, the sample proportion is going to be is going to be found by computing the number of successes, in this case, the number of women divided by the population or the sample size in that case, right? So points estimate for Q, the population proportion of failure is Q hat. So in this case, I was mentioning, we know P hat, we can find Q hat very easily. So we know that P and Q is equal to 1. So subtracting 1 from either one, we find the other one. So this is very simple. In a survey of 1,000 adults, 662 said that this is acceptable to check personal emails while at work. Find the point estimate for the population proportion of US adults who say it is acceptable to check personal emails while at work. So once again, we have a sample of 1,000 people. So we have that 662 of them said yes to checking that it's okay to check emails. And then, so we are going to find the sample proportion. So the sample proportion is going to be equal to the number of yeses divided by the sample size. So in this case, 662 divided by 1,000. So we have 66.2% of people. Can we know the value of Q? Of course, I just subtract 1 minus this point, and I'm going to get Q, right? So, so Q, let me write it down here. Q hat is going to be equal to 1 minus 0.662, right? If you have a calculator, you compute that, and you find the value, right? So you add the value of Q and the value of P, and you are going to get 1, right? So so that's good. So so we have the sample, the point estimate for P. So in order to find, so it's very simple, it's very similar to the other one. In order to find the population proportion, so in order to build a confidence interval using the sample proportion, so in order to infer the population proportion, we are going to be a C confidence interval for this population proportion. So basically, we are going to say, well, my population proportion lies between the left endpoint and the right endpoint, right? So where the left endpoint is the sample proportion minus the margin of error, and on the right endpoint is going to be the sample proportion plus the margin of error. How do we find the margin of error? So it's going to be very simple. Remember, we are using the normal distribution. So this is a binomial experiment that, as we can see, based on the sample size, is big enough. So it allows me to use normal distribution in this binomial experiment. So, so here, so the probability that the confidence interval contains the population proportion is C. So C is going to be the confidence level, right? So how big, how wide? So that's something that we have to determine. Very important here. So so we need to make sure before anything else that if I multiply n times p hat and n times q hat, those numbers are going to be bigger than 5. So once again, we did this before, and that is a very good test, because if these numbers are less than 5, so I cannot apply the binomial, the normal approximation to the binomial. So remember, we did it before. So in this case, this test is very, very important, because if we don't have these values bigger than 5, so we don't have any chance to apply the normal approximation. Okay, so then we have the level of confidence. So we find the C-score. So we use the standard normal curve, or we use technology. So we have been using technology to find the margin of error. We are going to use the C-score, and then we are going to take the square root to this, right? So this is the probability of success in the sample times the probability of failure in the sample divided by the sample size, right? So, so we are going to take this value, multiply it by the C-score. So we are going to add the left endpoint, the right endpoint, and then we are going to be happy. Okay. So let's see an example. So in a survey of 1,000 US adults, 662 said that it's acceptable to check personal emails while at work. So construct a 95% confidence interval for the population proportion of US adults who say that it is acceptable to check personal emails while at work. So remember, we already have the p hat, and then we found the q hat, right? So those values we are going to need, remember, in order to find these values. So we need p hat and q hat. So so then first of all, we are going to do the test. So we have to pass this test, otherwise we are not going to be able to apply the normal distribution. So in this case, I multiply the sample size. Of course, the sample size is super big. I probably don't need to do it, but still we do it because we want to make sure, right? So in this case, n times p hat is 662, way bigger than 5. N times q hat is going to be 338, way bigger than 5. We proceed to find the margin of error, and then so we have the C-score that corresponds to 95% confidence, and we are gonna find the left and the right endpoint. So can we do it? Can we do this easier? And basically, that is my goal today. So we have this Excel file. So we have the proportion. Let me make this bigger. So this one, I think I found it somewhere online. So I'm not taking any ownership of this. Very nice. The person found all these values. So this is the number of successes. So he's explaining, or she's explaining, how they found the formulas. So if you don't have to type anything here, as you can see, this is a big Excel function. I won't be able to do anything like this, but happily I don't have to. So we have values here. So So all these things are very, very nicely done. So, so in this case, what do we need to find these values, right? So, so here, make this smaller. So here we need the number of successes in the sample, right? So in this case, the number of successes is 662. So out of 1,000 people, so 662 said yes. So we have to use the yellow cells. Then we have the sample size, in this case is 1,000. And then we have the level of confidence. Remember, this is different from alpha. This thing is asking me the level of confidence. So in this case, it's 95%. I can either say 95%, oh, 95%. And as you can see, I didn't do anything. So this found the C-score based on the confidence level. They found the sample proportion, the standard error, the margin of error, and the lower and the upper limits. So that's very cool because you have these values. So at some point you might have some more information, whether you have the population proportion and the sample, the size of the population, and the sample proportion. You might have it, but in this case, our goal is to make this approximation using the C-score. So here, we don't have to do almost anything, and I am sorry to make you guys kind of a little lazy, but so in this case, we have the C-score, so all this computation is done in 25 seconds. So as you can see here, we have the margin of error, 0.29, and then we have the different confidence intervals. So in this case, we can do the, so we have to write this here. So with 95 confidence, we can say that the population proportion of adults. So this is very important because I am claiming that the population proportion of adults who says that it's acceptable to check emails while at work. So probably I don't know exactly what the proportion of people is, but based on my sample and based on this confidence level, I am able to claim that I'm confident that this approximates to the population, okay? So we also can find the sample size based on the population. So given a C confidence level and a margin of error, so the minimum sample size needed to estimate P is going to be given. So this is the proportion of success, proportion of failure in the sample, multiplied by the square of C divided by E. So we can build this formula very, very easily. So this formula assumes that an estimator for P hat and Q hat, right? So if not, if we don't have any estimation, so all we can do, like for example, we don't know the population proportions. So we can make a very, very strong assumption and use 50% and 50, and that is gonna give me like a very standard sample size, right? Of course, if I know the probability of success in the sample and the probability of success, of failure in the sample, I can make this value more accurate. But for example, you are running a campaign, you are looking at the results in the next, or you are trying to project how your candidate is going to perform. You don't have enough information, and you want to do a survey. You say, well, let me use a 50-50 and see how it works, okay? So I think I exhausted my time. Is there any question? Is there any question?